Systems of linear inequalities. So first let's start with some vocab. Okay. So when we are graphing these inequalities, sorry about that, we must make sure that y is isolated, okay? If we're just plugging it into an equation and trying to solve that way, it's not a huge deal, but when we're graphing, it's gonna be helpful. Okay, and then if you guys recall from Algebra 1, we talk about dashed lines and solid lines. So a dashed line, this is what it looks like, versus a solid line. And then, if you recall as well, based on the inequality is where we would shade. So for a dashed line, if we were shading above, that means this is greater than, or if we were shading below, it would be less than. Versus a solid line, the only difference is this is now greater than or equal to versus less than or equal to. When finding solutions, if we're given a inequality and they give us a point and they say, is this a solution? One way to do this, it would be to substitute it into the original, and if it creates a true statement, then it is a solution. So we would only use this part if it's like an equation. They give you an equation, they say plug it in, okay? And recall that a true statement is when we look at it, it looks correct. So for example, 5 is greater than 2. That's a true statement. 3 is less than or equal to 3. That's a true statement. Or versus if we were looking at solutions on a graph, the solutions we would look at would be in shaded areas or on solid lines. Okay, so let's look at an example. First example says, is the point -2, 7 a solution of the following system? So what we need to do is we need to plug in -2, 7, so our x and y, into each of these inequalities and see if we get a true statement. So for y greater than or equal to x plus 4, we're going to plug in 7 for y and -2 for x. So 7 is greater than or equal to -2 plus 4. So this is 7 is greater than or equal to 2. This is a true statement, which means this is good. Then we have y minus x less than or equal to 10. Y is 7, so 7 minus a -2 for x is less than or equal to 10. That's the same as saying 7 plus 2 is less than or equal to 10. 9 is less than or equal to 10. True statement. So this one's good. Then we have y greater than -3x. So in order to plug this in, we have 7 is greater than -3 times -2. So 7 is greater than 6. True statement. Since all of these are true, that tells us that -2, 7 is a solution. Okay. Which means if any of these are false, then it's not a solution. So this one could be true, this one could be true, but let's say this one was false. Then that means this point is no longer a solution. They all have to be true in order to be a solution. Okay, let's look at number 2. Number 2 says determine if the coordinates below are solutions to the system of inequalities shown. Justify your answers. So now we're looking at each of these points and seeing where they fall on the graph. So -1, 1. Since it falls in the shaded region, we would say, yes, this is a solution because it's in the shaded region. Okay, then we look at this next point, 0, 0. So right here at the origin, we would say, yes, this is a solution because it's on a solid line. Part C, 0.5, negative 1. So 0.5, negative 1 is right here. Notice how this is not only on a solid line, but also on a dotted line. And remember, in order for it to be true, in order for it to be a solution, it needs to meet every single one of those requirements. So since this falls on a dotted line, this is not a solution. So we would say no, it's on a dotted line, even though it's also on a solid. Okay. And then lastly, we have negative 2, 4. So negative 2, 4, which is a solution, yes, because both, and that's important, both are solid lines. Okay, let's look at number 3. Number 3 says graph the solution set, and it gives us 3 inequalities to graph. Notice how all of these inequalities all start with y, which means we don't need to change anything here. We can just go straight to graphing. So I'm going to highlight them 3 different colors. That way you'll be able to see where they fall on the graph. So starting with the first one that I highlighted in pink, we have y is greater than or equal to x minus 2. When we're graphing linear equations, we always graph the y-intercept first, so negative 2. And then we do rise over run for the slope. So since our slope is 1, I'm going to go up 1, left 1. Or sorry, right 1. Up 1, right 1. And I'm going to keep doing that until I have the entire graph covered. So you'll notice the difference between when we would graph before versus when we would graph now is that our precision here matters. So this is not just a rough sketch. This is us graphing, and the precision and the accuracy matters. So since this is y is greater than or equal to, this is going to be a solid line. And since it's greater than, we're going to shade up. So instead of shading the whole thing, learn from my mistake, I'm just going to draw some arrows showing that I'm shading up. And then at the end, where all our arrows are pointing, it's going to be our solution set. So now let me go to the second equation. I have 2 as my y-intercept, and I have negative 1 as my slope. So now I'm going in the opposite direction. And since it is less than, it's going to be a dotted line, and I'm going to shade below. And then I have 4x plus 4, so I have 4. And technically for 4x, I should go up 4, right 1, but I don't have room for that. So I'm going to go down 4, left 1, down 4, left 1. And since it's less than or equal to, it's going to be a solid line. And since it's less than, it's going to go down. So I know this looks like a mess, okay? But we're trying to visualize where are all of these shaded regions crossing. And where they all cross is going to be our solution. Well, notice the blue is going to the right, the red is going up, and the green is going down, which means this little area here, this triangle, is where they all meet. So this triangle area is our solution. Number 4. Notice now that our equations no longer have y isolated. So I'm going to have to isolate that first. So in order to do that for the first one, I'm going to have to move the 3x over. So that means this becomes y is greater than or equal to negative 3x plus 3. For the next one, I'm going to have to move the positive x over. So I have y is less than negative x minus 8. But for this last one, I'm going to have to do 2 things. I'm going to have to move this 2x over and eventually divide by negative 3. So first, moving this over, I have negative 3y is less than or equal to negative 2x minus 6. And then dividing everything by negative 3, I have y is less than or equal to 2/3 x plus 2. And I just made a mistake right here. which I'm about to mention, because if we divide by a negative, our inequality flips right here. So I'm going to write a little note over here. So dividing by a negative flips the inequality. And we see that here, how we went from less than or equal to now greater than or equal to. Okay. Now that I have all my y's isolated, I'm going to graph them. Okay, so starting with the first equation, I have a 3 as my y-intercept, and I'm going to go down 3, right 1. So down 3, right 1, down 3, right 1. Okay, and then since this is y is greater than or equal to, we know it's a solid line, and greater than means we're going up. Okay. Then I have y is less than negative x minus 8. Well, you'll notice that negative 8 is kind of off the graph here. And negative x means I should be going down 1, right 1, but I'm going to do the opposite. I'm going to go up 1, left 1. So it's going to look something like this. And I do know it is off the graph. But since it's less than, it's going to be a dotted line, and my arrows are going to go down. Lastly, I have that 2/3 x plus 2, so plus 2. And then I'm going to go up 2, right 3, or down 2, left 3, down 2, left 3. And this is greater than or equal to, so I have a solid line where it is going up. Okay, well that's strange. Notice how these ones are going up, these ones are going up, and these ones are going down. Even though these ones cross at a particular area, these green ones are going in a completely opposite direction, which means this does not have a solution. There is no solution set because there's not an area where all 3 shaded regions are crossing. Let's look at number 5. Number 5, you're going to notice now that we're going to get some vertical and horizontal lines. So for the first one, y is less than negative 2. So I have negative 2. It's a dotted line because it's less than, and my arrows are going to be going down. For x is less than negative 1, I find negative 1 on the x's. It's going to be a dotted line, and my arrows are going to the left because it's less than. That's where all the small x's are. And then I have 1/2 x minus 3, so minus 3, and 1/2 slope means up 1, right 2, up 1, right 2, up 1, right 2, down 1, left 2, down 1, left 2, and this is also a dotted line, and since it's greater than, this is going to be going up. So you'll notice where they all cross is going to be in this little area. I drew it a little too far, in this little trapezoid type area right here. That is our solution. Number 6. Now we have 4 lines that we're going to have to graph and shade. So starting with the first one, we have y is less than or equal to 3. Well, here's 3. It's a solid line because of that equal, and less than means I'm going down. X is less than 2. I find 2. It's going to be a dotted line, and less than means to the left. Then I have x is greater than negative 4. Well, here's negative 4. Dotted line because it's greater than and not equal to, and then that means I'm going to the right. And then lastly, y is greater than or equal to negative 3. Here's negative 3. It's going to be a solid line, and that's going up because it's greater than. So if you notice, all of these arrows end up going and overlapping and pointing to this middle square area. So this is our solution set. Now, on the last part of these notes, we are going to take a graph that's already graphed, and we're going to write the equations for each of these inequalities. And before I do that, I want to label each one so I know which one I'm talking about. So I'm going to label this 1, 2, and 3, and I'm going to start right here at number 1. Okay, so on number 1, the first thing I notice that this is a solid vertical line. Since it's a vertical line, I know it starts with x. And since it's solid, I know I'm going to have a greater than symbol. Greater than or equal to or less than or equal to symbol. And then notice where the shared area is right here, this is going to the right. So since it's going to the right, I know it's going to be greater than or equal to. So x is greater than or equal to -3. Then I do number 2. Number 2 is right here. I first find the y-intercept, which is right here at -2. And then I find another good point so I can find the slope, and this goes up 1, right 2. So that's 1/2 x. And since this is going up, it's going to be greater than, and since it's a dotted line, it's not going to have an equal to. So this is y is greater than 1/2 x minus 2. Lastly, I have the third line right here. I'm first going to do the y-intercept, which is at 1, so plus 1. And then I'm going to find the slope. So this is up 1, right 2. So this is a -1/2 x. And since this is getting shaded down, this is going to be y is less than -1/2 x plus 1. Okay, number 8. Number 8, first thing I'm going to label each of my lines. So 1, 2, and 3. And I'm going to start with number 1. So number 1 has a y-intercept of +2. And then for the slope, this is up 1, up 2, left 1, left 2. So this is 2 over -2, which is -1. So this is -x. And since this is going in this direction where the shaded are, it's going to be greater. So this is y is greater than or equal to -x plus 2. Second one. First, I find the y-intercept, so it's also at +2. And then if I find another point right here, I notice that this is down 1, 2, 3, right 1. So -3, -1, so this is -3 over -1, which is +3, so this is 3x. And since this one is also going to the right, it's also, well, actually, let's see. This one's actually going down this way. It's getting shaded down this way. So this is less than, so this is y is less than 3x plus 2. And then lastly, number 3, first we find the y-intercept at -1. And then we find another good point, so here, so this is up 1, right 1, 2, 3. So this is 1/3 x. And this is getting shaded up, so this is y is greater than 1/3 x minus 1.